Good morning, everyone. It's a great pleasure to be here to attend this wonderful international conference. I'm Chuan Wen from the University of Exeter in the United Kingdom. For today's talk, I'd like to discuss the nanoparticles and the themes to enhance the melting performance of fast-changing materials for thermal energy storage. Before the presentation, I'd like to introduce myself very briefly. I have been working on clean energy for more than 10 years with a focus on the sustainable development of fossil energy as well as the renewable energy, including solar energy and hydrogen energy. Also, I have participated in several projects for fuel technologies in gas turbines and diesel engines. To date, I have been awarded 2 medical fellowships at the Technical University of Denmark and the University of Nottingham. I have been also granted 3 Young Research Awards from the Society of Petroleum Engineers, International Chlorine Council, and Australia-China Natural Gas Technology Partnership Fund. I have also participated in a few professional activities. For example, I have served as topic editors for Fluids and Energies and guest editors for Heat Transfer Engineering and Heat and Mass Transfer. I also worked as a conference secretary for the 16th UK Heat Transfer Conference and also served as session chairs for several international conferences. And also I have been the external reviewers for the National Science Foundation from Poland, Czech, South Africa, and so on. Now let's have a look at the fast-changing material for the thermal energy storage in solar-based heating systems. As far as we know that the climate change is one of the main concerns for our current society, not only from our academic colleagues, but also for the general public. And the extreme weather is becoming more and more frequent in the recent years. For example, that we had the flood in Europe and China in this July. And to combat the climate change, on the one hand, we need to develop new technologies for the sustainable development of fossil energies. On the other hand, we need to increase the utilization of the renewable energies, including the wind energy, solar energy, hydrogen, geothermal, and so on. And this figure shows the CO2 emissions in the different sectors in the UK, and we can see that the CO2 emissions from the homes and communities is in the top third in the UK. And for this purpose, we have to develop and increase the renewable energy to mitigate the CO2 emission from our buildings. And for the UK, we have the following solutions for our heating and cooling systems. For example, we will try to increase the utilization of hydrogen, heat pump, solar, geothermal, and other new technologies. For this purpose, we tried to integrate the fast-changing material as the thermal energy storage and the solar energy to upgrade the energy efficiency of the built environment. This method will not only improve the energy efficiency of the modern building environment, but also will mitigate the CO2 emission from the homes and communities in the UK. And in this study, we tried to evaluate the performance of the phase change materials in the solar-based heating systems. And we will try to integrate this phase changing material as the thermal energy storage medium for the improvement of the energy efficiency of the building environment. But as we know that one of the disadvantages of the phase changing material is the lower thermal conductivity. So in this study, we will try to evaluate the integration of nanoparticles and fins to enhance the melting process of the phase changing materials. And for this purpose, we tried to develop a safety model to evaluate the enhancement of melting process of the phase changing material. And for the numerical simulation, we will use the conservation equations of mass, momentum, and energy equations to govern the flow behavior of the phase changing material in the thermal energy storage systems. And the most important that we need to describe a source term which is related to the momentum sink due to the reduced porosity in the material. And for the implementation of the numerical studies, we need to describe the initial and boundary conditions for this phase change behavior of the thermal energy storage medium. And here we tried to validate our developed safety model and compared the data from the available publications in the applied thermal engineering. And in the right figure, we can see that the numerical averaged temperature agrees well with the experimental measurements. So we can say the developed safety model is suitable for the prediction of the melting process of the phase changing material for the thermal energy storage. And these two figures shows the averaged temperature distribution by 3 cases, including the pure PCM and fins, PCM fins and nanofluid. We can see that the integration of fins and nanofluids will enhance the melting process of the phase changing material. And also from this figure, we can see that the effect of the gravity will result the lower temperature at the bottom of the tube. And these two figures shows the liquid fraction distribution in these 3 cases. And we can see that for the pure phase changing material, it will take about 80 minutes to reach a fully melt state of the phase changing material. And for the case of the PCM fins and the nanofluids, we can see that it only need 25 minutes to achieve a completed melted state of the phase changing material. And here's some concluding remarks and future studies. In this presentation, we try to integrate the Cooper nanoparticles and triangular fins to enhance the melting process of the fast-changing material for the thermal energy storage in solar energy heating systems. And the integration of copper nanoparticles and triangular fins is of 3 times efficiency than the pure fast-changing materials. And in the future, we will try to figure out the flow and thermal behaviors of the nanoparticles in the fast-changing materials, which will be carried out in 3-dimensional numerical studies. And also, we'll try to figure out the rules of the fins in the melting performance enhancement of the fast-changing material, including the types, the configurations, surface structures, and so on. Finally, we'd like to thank the financial support from the Mercury Fellowships. And here's my presentation for the fast-changing material. Thank you for your time.